All right, so we are going to learn how to multiply complex numbers together, how to take the power, take a complex number to a power, and then how to divide complex numbers, and then also how to find the roots, like square roots, cubed roots, fourth roots of a complex number. So there are ways to do these in rectangular coordinates, which I might remind you later what those would actually look like, but let's just use the polar forms for now. So for the product rule, complex number z times complex number w, we would take the magnitude of z times the magnitude of w, and then we multiply that through the polar form of cosine plus I sine, and we add the angles together. So let's just do this formula really fast using these examples. So I just pulled these out of my head when I was writing this up. So 3 times the cosine plus I sine of 30 degrees, and I decided to do them in degrees too. I hope that's okay. And then W is 2 times the cosine plus I sine of 45 degrees. So using this formula and doing this little example, we would get Z times W. I'm just going to write it all out so we know what we're doing. Z times W would be the magnitude of Z, which is just this number in front, so 3 times the magnitude of W, so just this number in front, which is 2, and it's going to be that times cosine plus I sine of our angles added together, so 30 plus 45. So that would give us a new complex number, 6 times the cosine plus I sine of 75 degrees is our new polar expression for the complex number that results when we multiply these two complex numbers together. Now, if 75 had been a number that we actually knew the exact values of, we could go ahead and multiply this out and put it back in rectangular form. But we will get to practice that in our other examples later in this section. Okay, so that's the product rule. That's multiplying two complex numbers together. So then we have the power rule, which has a fancy name after some mathematician dude named de Moivre, I think is how it's pronounced. I could be wrong. It's French. Anyway, this one is just where we're doing a power. So it would be like we're finding z to the fourth power based on what I've written here. So here's our formula. Z to the nth power is equal to the magnitude of z to the nth power times the cosine plus I sine of n, the power, times the angle theta. And that's for any natural number n. So natural number would be our counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. Okay, so if we have z is the same as it was in the previous example, 3 cosine plus I sine 30, and we're doing a power of 4, we use de Moivre's theorem, we're just going to go 3 to the fourth power times the cosine plus I sine of 4 times 30 degrees. What, Adrian? Dis-moi. Okay. 3 to the fourth power. What's 3 to the fourth power? Help me out. I didn't plan ahead for this. Is it really? 3 times 3 is 9. Times 3 is 27. Yeah, it is 81. Sorry. Okay, cool. I don't know why I was doubting it. So 81 times cosine plus I sine of 120 degrees. So there, we just found a new complex number from a complex number taken to a power of 4. Okay, the nice thing about this is if you were doing this with rectangular coordinates, think about this being a binomial, a plus bi, and you're taking it to the fourth power, you would be either multiplying that 4 times or you would be using that thing we learned at the very end of the term in Math 1050, the, what was it, Pascal's triangle binomial theorem thing, to multiply it out instead. So using this formula instead is a very simple way of multiplying out the power of a binomial complex number because we do it all in polar form. Okay, now let's look at the quotient rule, kind of follows along just what we would expect from the power rule. I mean, the product rule. The product rule was we multiply them together and add the angles. So the quotient rule is we divide the magnitudes and we subtract the angles. And of course, we can't divide by 0. So just be aware of that. So if we're finding z divided by w, we are doing 3 divided by 2 times the cosine I sine of 30 minus 45, which would give us 3/2 cosine I sine, oops, so 3/2 cosine I sine of negative 15 degrees. And negative 15 degrees would agree with our rule that we're going between negative pi or negative 180 and positive pi or positive 180. It would fit within that if we're following that we learned last time. So here's a new complex number that came from dividing two other complex numbers. Okay, do we understand the rules? Let's go ahead and stop this video and upload it, and then I'm going to go through example 1.